Hi, I'm Emmy, this is Lauren, and this is Ashley. Today we're going to be showing you the chemistry behind baking a chocolate cake. To some, chemistry of cooking may just seem like taking ingredients out of a fridge, mixing them together, and just popping them in the oven. But as we learn about chemistry, we know more and more that there's science and intricate chemistry involved in each step. So we're going to be showing today the steps behind each ingredient in the chocolate cake, and we're going to be showing you just how they work together to make the end product.
We decided to bake the best chocolate cake with chocolate ganache. We preheated the oven to 350 degrees Fahrenheit, and we lined a 9x9-inch square baking pan with aluminum foil and spray. It is a well-known fact that if one leaves a cake in a pan without greasing or buttering beforehand, it will undoubtedly stick like cement to the baking pot. This is mainly because coating a greased pan with a thin dusting of flour creates a barrier between the grease and the cake batter, which prevents the grease from melting and disappearing into the batter. Next, in a large mixing bowl, we combined eggs. Eggs, as simple as they sound, are complex and react differently when heated, whisked, cooked, or combined with multiple ingredients. In general, proteins are made up of a chain of amino acids in egg whites that are globular proteins. This means that they are long protein molecules that are curled, twisted, and folded up together, which are kept tightly by weak chemical bonds. When eggs are whisked or beaten, the air bubbles become incorporated into the watery solution. Just as heating uncurls the egg proteins, the air bubbles have the same effect. This is because water and amino acids are attracted to one another. Many proteins in egg yolk can act as emulsifiers because they have some amino acids that repel water, and some amino acids that attract water. Mix egg proteins thoroughly with oil and water, and one part of the protein will stick to the water and another part will stick to the oil. Think baking soda and baking powder. Are the only ways to give you baked goods a lift? Think about it. Whipped egg whites are also a leavener. Egg whites trap air bubbles into the batter, so then whisked, egg whites are folded into a batter. They hold up the air in and help the baked goods in question attain a light, puffy rise.
Next, we add vanilla extract, which is made by the process of extraction to change the solid bean into the liquid that is kept in most pantries. Vanilla contains different molecules that include tannins, polyphenols, ethers, alcohols, acetyls, heterocyclics, phenolics, hydrocarbons, esters, and carbonyls. In the process of extraction, the pod of vanilla beans is placed in a solution of ethanol and water, which produces the molecule vanillin that is dissolved by the form of ethanol because the bonds in the ions can be broken by substances in the ethanol. The other molecules can be dissolved in water. This solution extracts the flavors from the pod and makes the common vanilla extract used in this recipe. Next, we add coffee to enhance the flavor of the chocolate. Chemistry is implemented in the roast of the coffee beans and the growth conditions that include temperature, soil acidity, and humidity. The chemical properties, which later affect the flavor of the coffee, also change as the coffee beans are roasted in a process called caramelization. Caramelization is the process in which polysaccharides are oxidized, and it's a non-enzymatic browning process. The byproducts of caramelization are three forms of the compound carmelin: C36H50O25, C12H18O9, and C125H188O80. This caramelization process turns the beans over time into charcoal. This produces the well-known flavor that is found in this recipe. Next, we add cocoa powder, which gives the cake its characteristic chocolate flavor. The rich powder is derived from cocoa beans, which are treated with an alkaline substance that neutralize the acidity of the bean and give it a more mild and pleasing flavor. The cocoa bean does not lose its acidity, however. Cocoa powder's acidity is an advantage since it causes the proteins in baked goods to set rapidly. When the powder is mixed into the cake, it not only gives it a flavor, but also acts as a flour that helps set the cake. Together, when the cocoa powder and flour mix with water, the proteins glutenin and gliadin bond to each other, producing what is known as gluten. When heat is applied to this gluten, the gluten network grows and allows the cake to rise.
Add the flour, baking soda, baking powder, salt, and whisk vigorously until batter has combined. Baking powder and baking soda are common and key ingredients in the processes of creating cakes, muffins, biscuits, and cookies. These foods do not require the use of yeast that bread calls for. However, it is just as effective and works twice as fast for a reaction to occur. Baking soda differs from baking powder because it has only one ingredient, sodium bicarbonate. It reacts with acids such as yogurt, buttermilk, or vinegar. Its reaction occurs instantly and releases carbon dioxide in the form of bubbles as a result. Instead of the one ingredient in baking soda, baking powder has two, carbon bicarbonate, and an acid called monocalcium phosphate. The two do not react together until something wet is added into the mixture, in which chemical leavening will then take place. There are two types of baking powder that can be bought in stores: single-acting and double-acting powder. The single-acting baking powder reacts instantly as it forms carbon dioxide. Next, pour batter, which is a loose and fairly runny batter, into prepared pan and bake for about 25 minutes, or until top has set and a toothpick or cake tester inserted in the center comes out clean. Allow cake to cool in pan completely. Heat creates chemical reaction and allows for new bonds to form. As the batter cooks in the oven, an endothermic chemical reaction is taking place. It aids the baking powder to react and expand the cake. This causes the cake to be fluffy. Where baking may seem simple, many processes of chemistry are used in the production. These processes include caramelization, oxidation, and the endothermic reaction of putting the batter in the oven. The chemical processes work together to produce the confection that is well known and well loved, chocolate cake.